Hello, cosmic enthusiasts. Get ready for one of the most extraordinary stories in recent astronomy. For the very first time in history, a visitor from another star system is making a close approach to the red planet. The interstellar comet, 3I Atlas, a true traveler among the stars, is about to pass by Mars in an event that scientists around the world are calling the opportunity of the century. Imagine an object born orbiting another star, tens or even hundreds of light years away. A comet that was ejected from its cosmic home millions of years ago and has wandered through the absolute darkness of interstellar space. Now this lonely traveler is crossing our solar system, and on its hyperbolic journey around the Sun, it will pass extraordinarily close to Mars. The approach of 3I Atlas to Mars represents something truly unprecedented. While our own planet Earth occasionally receives visits from local comets, we have never before had the chance to observe up close the interaction between a planet and an interstellar object. Even better, we have spacecraft orbiting Mars, ready to capture every second of this historic cosmic encounter. Let's dive into the technical details that make this event so remarkable. 3I Atlas will pass at a distance of about 5 million kilometers from Mars, a gap that may sound vast, but in astronomical terms, it's a near miss. For comparison, that's roughly 13 times the distance between Earth and the Moon. It might seem far, but remember, we're talking about an object coming from another star system. The relative speed of the encounter is breathtaking. The comet is traveling at approximately 40 kilometers per second relative to Mars. That means in just 1 second, 3I Atlas covers the distance between São Paulo and Santos 40 times over. This extreme velocity is one of the telltale signs of its interstellar origin. Native comets within our solar system simply don't move this fast when passing by Mars. What makes this encounter even more spectacular is the timing. During its approach, 3I Atlas will be in a phase of intense activity. The sun's heat will be vaporizing its alien ices, creating a brilliant tail that could stretch for millions of kilometers. Mars essentially will be diving through the tail of an interstellar comet. Here's where the story becomes truly thrilling. Mars is currently the most studied planet in the solar system after Earth. A veritable fleet of spacecraft orbits the red planet, and all of them are being repositioned and reprogrammed to observe this historic event. The Mars Reconnaissance Orbiter, with its high-resolution cameras, is capturing detailed images of the comet against the stellar backdrop. MAVEN, designed to study the Martian atmosphere, has turned its instruments toward analyzing the chemical composition of the comet's tail as it sweeps past the planet. The European Mars Express and India's Mars Orbiter mission have also joined the action, each contributing their unique instruments to this international effort of observation. But the true stars of the show are the rovers on the Martian surface. Perseverance and Curiosity, our robotic geologists on Mars, are pointing their cameras toward the Martian night sky. For the first time in history, we have mechanical eyes on the surface of another planet watching an interstellar comet. The images they recapturing, Comet 3I Atlas shining in Mars' butterfly-colored sky, will be iconic for generations to come. Oh ChatGPT DISA, the close approach to Mars is providing extraordinary scientific opportunities. First, there's the chemical composition. As the comet passes by, spectrographic instruments are dissecting the light emitted and reflected by its coma and tail. Every element and molecule leaves a unique fingerprint on the light spectrum, and scientists are meticulously cataloging the alien chemistry of 3I Atlas. The initial findings are fascinating. The carbon-to-oxygen ratio in the comet's gas is significantly different from that of solar system comets. Unusual abundances of complex organic compounds suggest that the nebula where 3I Atlas was born had a very different chemistry from our own primordial solar nebula. Traces of heavy elements have also been detected in surprising concentrations, possibly indicating that the comet's parent star was older or had a different nuclear fusion history than our Sun. The physical structure of the nucleus is also coming into focus. High-resolution observations from the Mars Reconnaissance Orbiter suggest that the nucleus of 3I Atlas is highly irregular, possibly elongated like Oumuamua. This may indicate that interstellar objects tend to have strange shapes, perhaps the result of violent collisions during their ejection from their home systems, or simply because small objects in the universe naturally take on irregular forms. Although 3I Atlas is moving far too fast to be captured by Mars's gravity, there is still a measurable gravitational interaction taking place. Orbital dynamicists are measuring, with nanometric precision, how Mars's gravity slightly bends the comet's trajectory. These measurements may seem trivial, but they provide valuable data about the comet's exact mass, crucial information for understanding its internal composition. There's also the fascinating possibility of atmospheric interaction. While Mars' atmosphere is thin, only about 1% the density of Earth's, it extends far above the surface. If dust particles from the comet's tail enter the upper layers of the Martian atmosphere, we could witness alien meteors, shooting stars made of material from another star system, burning up in the Martian sky. This close approach is generating data that will keep scientists busy for years. Every captured spectrum, every high-resolution image, every trajectory measurement adds pieces to the puzzle of how 3I Atlas was formed, how it escaped its home system, and what its journey through interstellar space can teach us about the nature of the interstellar medium. But perhaps the most profound aspect is philosophical. For the first time, we are studying material from another star system, not through light captured by telescopes, but through direct analysis of its chemical composition. It is the next best thing to sending a probe to another star system. It is as if another star system sent its samples to us. The close approach with Mars also highlights something wonderful about where we are as a civilization. We have robots on another planet, and those robots are observing a comet from another star system. Think about the beautiful absurdity of that sentence. In just a few decades, we've gone from barely being able to place satellites in Earth's orbit to having a fleet of spacecraft studying interstellar visitors from beyond our world. As the Perseverance and Curiosity rovers photograph 3I Atlas, they are essentially witnessing a meeting between two objects of completely different cosmic origins. Mars, formed 4.6 billion years ago in the solar nebula, and 3I Atlas, born around another star in an unknown time and place. This chance encounter, observed by machines we built and sent across 225 million kilometers of empty space, represents one of the most remarkable moments in human space exploration. The passage of 3I Atlas by Mars will be brief, just a matter of days on the cosmic scale. But the images captured, the data collected, and the discoveries made during these few days will echo through science for decades to come. Each observation teaches us not only about this specific comet, but also about the entire population of interstellar objects that must be out there, drifting between the stars. After passing Mars, 3I Atlas will continue its journey toward the Sun, make a tight turn around our star, and then head off forever into interstellar space. But it will leave behind something precious: knowledge. Knowledge about the diversity of planetary systems, about the chemistry that may exist in other corners of the galaxy, and about the processes that connect stars separated by light years through these wandering cosmic messengers. The close approach of 3I Atlas to Mars is just the beginning. With ever more powerful telescopes being built, like the Vera Rubin Observatory, set to begin operations soon, we will detect more and more interstellar visitors. Some will pass by Earth, others by Venus, Jupiter, or Saturn. Each encounter will be a new opportunity for discovery, and who knows, perhaps one day we will have spacecraft fast enough to intercept these visitors, send probes to land on their surfaces, collect samples, and bring them back. Until then, events like 3I Atlas's approach to Mars are our best windows into worlds beyond our solar system. So the next time you look up at the night sky and see Mars as a bright red dot, remember, at this very moment, that distant world is receiving a visitor from the stars. And we, through our mechanical eyes in orbit and on the Martian surface, are witnessing every second of this extraordinary cosmic encounter.